Hello and welcome to the second video of our series about noiseless single coils. This video is going to reference a lot of things discussed in the first, so if you haven't watched it yet, I suggest you do so before watching this video. It may not make a lot of sense if you don't. Part 1 inspected the mechanics of how a noiseless single coil works by comparing their operation to a humbucker. Noiseless single coils are typically voiced to be replacements for traditional single coils. So let's compare these designs and discuss the difficulty faced in getting the traditional tone in this contemporary design. We have four primary factors that define the tone of a pickup: capacitance, inductance, resistance, and frequency cancellation. Here's the formula illustrating how these things are related to the pickup's resonant frequency, the biggest factor of what a pickup will sound like. The string sensing length window is also a factor, but as it's identical between the designs, we'll disregard this. If we annotate this formula with what each letter means, we'll end up with something that makes a bit more sense. Now, if we combine these into a final formula, we want the top stack minus the bottom stack to equal single coil. Let's go into each factor individually to see how they work in this formulation. Inductance is, not entirely, but simply enough for our uses, the output of the pickup. We don't need to pay a great amount of attention to this, as long as it's not a huge quantity out. We'll go into the reason as to why this is later on. Next is capacitance. As the name suggests, this is related to capacitors, like the one found in your guitar's tone control. However, unlike that one, the capacitance of a pickup coil is significantly less, resulting in a lesser effect than turning down your tone control. Essentially, capacitance is the amount of treble in your tone, with more capacitance being less treble. Let's go back to inductance now. As I previously said, this is essentially an output measurement. It would be logical therefore to assume duplicating the inductance of a traditional single coil when designing a stacked single coil would be the way to output match the two designs. This is halfway correct. We need to take into account the lower subtractive coil, but after we've done that, it is correct. However, because of the nature of a pickup being capable of being lowered and raised by the mounting screws, we can compensate for discrepancies between output levels within a reasonable range, so this value isn't critical. Now let's inspect capacitance closer. Capacitance is formed in the coil, or coils, by parallel wires bleeding through some of the electrical charge to their neighbours. It starts with a charge in some of the wires, which then in turn charges the surrounding wires, opposing the original charge throughout the coil. This bleeding has the most significant effect on high frequency treble. This effect is more significant as our layers are close together, and our wires are closer together when we wind with thinner wire. The basic rule is, the thinner the wire, the less treble. This also applies to how many wires there are. More wires results in more capacitance. This is why we typically find high output pickups to be darker sounding than their low output counterparts. As we have two coils worth of capacitance instead of one, we run into our biggest hurdle. The top coil usually needs to be more powerful than the standard single coil to compensate for the subtraction of the bottom coil. This means more wires and more capacitance as a result of this, as previously discussed. This issue is further compounded when we take into consideration physical constraints to make the pickup actually fit into the guitar. To do so, we're making the coils smaller. Smaller coils with more wires usually means thinner wire, and thinner wire also means more total capacitance. Now this is essentially where the whole problem of getting the tone of a traditional single coil comes from. But there is a little quirk to the design that actually works in our favour. The frequency cancellation effect predominantly works in the bass frequencies, meaning that, when we're ignoring every other factor in play, our second coil makes our pickup brighter. This opposes the effect of the increased capacitance, which acts to make the pickup darker. When we design the two coils, we can make them to a formula where the two factors work against each other in a way that results in our final product ending up with a similar tone profile to that of the traditional single coil. This of course is much easier said than done, but we'll start looking into what goes into the design of a great sounding stacked pickup in the next video of this series.